Hello and welcome to the new chapter, Chapter 3. Today we're going to be learning a little bit more about sines and cosine graphs. Now, hopefully you have this worksheet in front of you that looks like this. Now, I want you to take a second and graph out sine on this first graph and cosine on the second half graph. Now, what you're going to do is type in your calculator sine of 0. Oh, that's not what I wanted. Here we go. If I type in the sine of 0, the answer is 0. So I'm going to just put 0 on the chart, and then I'm going to do the sine of 10. 10 degrees is this first number, that's 1.7. Each of these represents 0.1, so 1.7 would be somewhere around there. Now sine of 20, 0.34. Now I want you to keep doing this in your group. Pause this video and go from 0 to 90, doing every 10, and then skip every 90 after that. So once you get to 90, just do 180, 270, and so on until you get to 720. All right, now that we have these points, let's try to draw a curve. It's going to come up, and then it's going to come down like this. Come through, go back up, hit our peak, come down, and we're going to end back up at 720. Now take a second and do this for cosine. So pause the video. All right, now cosine starts at the top. Oops, that wasn't very good. It's going to come down and then come back through. Oop, I messed it up again. All right, so that looks good. All right, if I want to find the sine of 45 or the cosine of 65, the sine of 45, graphically, I can go up to this chart, and 45 is in here, so I can come up here and go over, and that will be 0.1, 0.2, 0.1, 0.2, 0.3, 0.4, 0.5, let's say 0.6-ish. We'll give you that value. So sine of 45 is about 0.6. That's a rough estimate. Now you guys can do that same with cosine of 65. Go over to 65, up and over. Now let's look at the ranges for sine and cosine. The max is 1, and the minimum is -1. So we'll say it goes from -1 to 1. Now if I want to find the inverse trigonometric functions of inverse sine of 0.4, I go to 0.4, 1, 2, 3, 4, go over and down, and that's what? About 20 degrees. So this one is about 20 degrees. Now you try it with the inverse cosine of 0.8 and see what you come up with. All right. Now, we've talked about this a little bit in the past, but one cycle is the distance from beginning until, or it's the part of the graph where it can travel until it starts again. So from here until here could be considered one cycle. The period is the distance horizontally between that. So say if this is goes from 4 to say 34, that period would be 30 because it takes 30 units to make a full cycle. The amplitude is the distance from this axis to the top, which should be the same as this distance to the bottom. This we can tell by our vertical stretch. Our phase displacement is how much we move to the right or to the left. So say if this is a cosine graph, I could say I move this to the right 2 units. So here our phase displacement might be 2 because we moved it to the right 2. If I moved it to the left, it would be negative units. Now my sinusoidal axis, that's a line that divides my graph right in half, and it's going to have some sorts of symmetry with our sines and cosines. So here's our sinusoidal axis. Let's say this started up at y equals 5. So my sinusoidal axis is y equals 5. All right, if we plot a graph of the transform function y equals 5 cosine theta. Now, we don't need to plot it. I think we can think that this 5 is a vertical stretch. Now, that vertical stretch is what we call the amplitude. So the amplitude of that function is 5. So what's the relationship between the amplitude and the vertical dilation? They are the same. What is the period of the transform function? So the period of this is still 360 because we didn't change it. So the period is 360 because cosine is 360, cosine of theta. Now if we plot the graph y equals cosine of 3 theta, that 3 is going to be a horizontal shrink. And the horizontal shrink is going to change the period. So instead of having a period of 360, that 3 will make it so it shrinks, so it'll have a period of 120 degrees. Now what does that x minus 60 do? Well, that x minus 60 is going to translate this to the right. All right, now we call that x minus 60 a phase displacement. And this theta minus 60 we call the argument. So if you ever hear me talk about the argument, what I'm talking about is what is in this position, the theta minus 60. So how is the phase displacement related to a horizontal translation? Really, it's the same thing. I'm just moving that graph to the right 60. Now the sinusoidal axis, if I want to move the graph up and down, I'll want to put something at the end of the function. So, so this would move the graph up 2. Now suppose we have this long function, 6 plus 5 cosine of 3 theta minus 60. Now the amplitude is my my vertical stretch. So my amplitude is going to be 5. My period I can get by, I know this is shrunk horizontally by a factor of 3. So 360 divided by 3 is 120. My phase displacement, I know that I just move it to the right 60. So that'll be a 60. And my sinusoidal axis will move up 6. So sinusoidal axis is up 6. Now we could plot this on our graph and see that all of that is true, but we don't necessarily have to do this. All right, now can you guys look at the worksheet and try this problem? The first thing it tells you to do is to graph these points. So can you guys graph these points on your graph? Now for the next part of the worksheet, I want you to pause the video and I want you to go through and try to figure out the equation. Each of the numbers, I think it's 2 through 7, give you one piece. So they're going to do one piece at a time to get you to the equation. So pause the video and go through it, and when you're done, listen to my explanation. All right. So now the first thing they want you to do is, now the period is 12. So 360 divided by 12, 360 divided by 30 gives you 12. So 30 is what we're going to be shrinking by. Also, you could take 360 divided by your period to find out your dilation factor, which is 30, and plug that in there. Now the Earth rotates 360 degrees around the Sun in 12 months. So kind of what 30 is probably the average number of days per month. All right, now what we do is we take that function and we move it to the right 7. I did something wrong here. This should be, because it's still shrunk horizontally, so it's going to be cosine of 30 theta minus 7. Now on your calculator, you need these extra parentheses, but when you're writing it, you don't necessarily. You could just say it's y equals 30 cosine, or cosine 30 theta minus 7. Either of these two is acceptable if I have a y equals in there. All right, now they're saying that we're moving it up 78.3. So you'd want to say y equals cosine of 30 theta minus 7 plus 78.3. And then we have an amplitude of 16.6. So that gets there. Now here I have the 78.3 in front. That's going to be the same thing as putting it on the back end. Now hopefully from there you guys were able to plot that and see that things fit exactly as they should. All right, so let's look at concavity. Concavity just tells us whether it's concave down, which means it's curving down, or concave up, which means it's curving up. There's these points in between where we call them the points of inflection. They're the points in between concave up and concave down. Those points are pretty important as we go on in math, and in pre-calc we just mentioned them. All right, now upper and lower bounds. Upper bound is going to be the where the highest point in our sinusoidal function is, and lower bound is where the low point is. And sinusoidal axis will be right in the middle. So here is your general sinusoidal equation. Y equals c plus a cosine b theta minus d, where a is the amplitude, or the absolute value of a, I should say. B is the reciprocal of the horizontal dilation. So that's not the period, which a lot of people get confused with. C is the location of the sinusoidal axis, and D is the phase displacement. Now, the period we can find by taking 360 times 1, which is just 360, over the absolute value of B. And there's a new thing called frequency, which is the number of cycles per degree, where you take B over 360. So you could just take 1 over your period to get your frequency. It's just the reciprocal. All right, now can you go to worksheet 3.2a? I'll do the first one and you can watch, and then I want you to do the other two. All right, the horizontal dilation factor here is 2. And this is a shrink by a factor of 2. So, yeah. So the period is not going to be 360, and now it's going to be 180 degrees. The amplitude is 3. The phase displacement moves it to the right 70, and the vertical displacement moves it up 4. So let's draw this graph. So first I'm going to move to the right 70. I'm going to go up 4. I'm going to draw a dotted line for my sinusoidal axis. And then I'm going to go up 3 and down 3 from that. Now, I think it's nice to make a little line showing your upper bound and then your lower bound. We're going to go 3 up and 3 down from our sinusoidal axis because that's our amplitude. All right. Now, we started to the right 70. We're going to do one complete loop by the time we get 180 degrees from 70. So that's like 250. Now let's see if this is an appropriate scale. If this is 70, this would be about 140. This would be about 210. So yeah, that seems reasonable. Cosine starts at top. It's going to end on the top. In the middle, it's going to be at the bottom. And then in between there, it's going to be on the sinusoidal axis. So we're going to come through, come down, come back up. Now it says 2 cycles, so we need to add 180 to 250 to get 420. So at that point, it's 420. And so we'll just fill in the rest of them. And it's going to come down through. And it's still going to go to the left, still going to go to the right, but all we're looking for is 2 cycles. All right, now I want to see you try to get through the rest of these. All right, here are some answers. Here's some answers from the first page: 30, 12, 4, -1, -2. Here's a graph of that where there's 2 cycles. Now in this equation, I had got y equals -3 plus 5 cosine of 6 theta minus 10. And if you want to find y if theta is 35, I just plugged it into this equation and got -7.33. All right, your homework for today is do these quickly, 1 through 10 and 1 through 11 odd. Good luck.